Hey team, it's Mr. Z. We're going to solve some inequalities with technology. Let's take a look. So the idea here is that you're going to essentially be solving these inequalities as if they were equations, but there is an extra bit to it. So looking at this first one, I'm going to take the inverse of -5 to both sides. This is going to result in the equivalent inequality of 4x squared being less than or equal to 14. I'm going to divide each side by 4. This is going to leave me with x squared is less than or equal to 14 over 4. I'm going to go ahead and reduce 14 over 4 to be 7 over 2 because I see that they're both even. Now, I'm going to take the square root of both sides, leaving me with x on the left and the square root of 7/2. So, x has to be less than or equal to the square root of 7/2. You would go ahead and plug it into your calculator and you'll get your solution. Now, this next guy, it's a little more complicated. Well, let me go ahead and get all of my terms on one side. So I'm going to go ahead and add 10.5 to both sides. And 10.5 does not have any common terms on the right side of the inequality. So it's going to produce 0 is greater than 1.5x squared minus 15.5x plus 10.5. Now, all these decimals are kind of clouding my vision. I see that the leading term is 1.5, so I'm going to go ahead and do a check. Notice here, A is 1.5, B is negative 15.5, and C is 10.5. These are the leading coefficients. I'm going to check if they're all divisible by 1.5. Well, this is equal to 1. How many times does 1.5 go into negative 15? Well, it's going to be negative. And you're going to go, and it doesn't quite go into it. You try, you get up to 15. It does go into 10.5 4 times. So, unfortunately, though, it does not factor evenly. So, I'm going to need to use technology to graph this guy. So let's go ahead and look. So I'm going to plug this into decimals. 1.5 to the x squared. Make sure I'm accurate. Minus 15.5. And then add 10.5. So this is what it looks like. I have to remember my inequality now. Going back to it, you see how 0 is greater than this. So if I flip it, we're in the common form where you're used to it. 1.5 x squared minus 15.5 x plus 10.5 is going to be less than 0. It is below the x-axis, is essentially where all these solutions are. So basically the solution to this guy is going to be a whole host of inequalities between the zeros, 0.729 and 9.605. So my solutions are going to be any of these numbers between them. They will create something that is less than 0. So my solutions are going to be x is going to be between, let's look at it again, 0.729. The other 0 is 9.605. All right, think about it. X is between it. So x is going to be hit like that. All right, next one. Oh gosh, even more complicated. Well, let me go ahead and add 6.6 to both sides. And I'm going to change the order of this guy. I'm going to write it in normal form. I'm going to write it as 0.8x to the fourth plus 2.2x to the third minus 12.4x squared plus 6.6. So this is just a lot of decimals, right? I'm going to go ahead and just plug this guy into Desmos. So it's going to go, let me clear my old one. It's going to be 0.8, 0.8x to the fourth plus 2.2x to the third minus 12.4x squared plus 6.6. And remember, I'm looking for the regions where it is below my x-axis. I'm going to actually have a couple solutions, which makes sense. There's 4 zeros. So the key points here are always the zeros. Click Desmos is nice because you can click. I get negative 5.513, 0.698, 0.808, and 2.652. So let's go ahead and make sense of these numbers. So my solution, I want it to be less than it. So I hope you can see that in this region, between this zero and this zero is a possibility. It's going like this, like a U. So any of the solutions between these two are going to work. Negative 5.1, let's see, negative 5.513. And then the second one is 0.698. So my x value could be between those 2 points. However, that's not the only solution. So looking at it, it's going to go above the y-axis or the x-axis and then come back down. And my second solution set is going to be between 0.808 and 2.652. 0.808 is going to be between x and the other one is 2.652. Notice how it's an inequality. My answer can be between these or be between these. I hope this helped. This is a little odd where your answers are not necessarily what we're used to when we're solving equations. That's because there's a whole host of answers that make it true. The idea is I like to use the benchmark of 0 because it helps me see, okay, do I look above or below my x-axis?